Now, as promised in our next video, this video, we're going to continue with our conversion from binary floating point to decimal. Last video, we did look into the decimal to binary, right? Now, it is vice versa. So that is also similar, which is 4 steps. For you to do in terms of standardization IEEE 754. So the binary to decimal floating point, step one, you're going to extract value of sign. This one is similar to your decimal floating point. First, you're going to look into sign, and sign is very easy. Normally, you're going to get full mark for sign because you only refer to whether it is positive or negative. Positive will be 0, negative will be 1. Second, extract value of bias exponent and bias value. Third is extract the value of fraction and apply basic equation. Let's take a look into the step by step. Example here, you have what is decimal number represented by single precision float. So it's give you already, and please remember, always remember, if it's mentioned single precision or it's mentioned double precision, either IEEE, sometimes it's not inform you that it's IEEE 754, but it's direct give you a single precision, so don't use different format. So single precision, you're going to have 1 for sine, 8 for your bias exponent, which is EB, and another one is 23 is your fraction. So here you know, okay, our sign is 1, then our number will be negative. And our fraction here, it is 0, 1, mean it is 1 for your fraction. So let's take a look how you're going to get your EB in terms of the reverse engineering equations or step and methods. So solution for step number 1, extract the value of sign. So you know already it is 1 equal to negative. So extract value of your bias exponent. This is the bias exponent. You can extract the value, and let's say, please make sure you remember EB equal to E prime plus with your B, and your B I mentioned already, it's fixed already. Fixed means it's 1 to 7. Now I want to convert this binary to decimal. Give me some time. I open my calculator. Binary to decimal. 1 0 0 0 0 0 0 1. So when I convert to decimal, I get 1 to 9. 1 2 3 4 5 6 7 8. 1 2 3 4 5 6 7 8. So I get 1 to 9 for my decimal. So this value is my 1 to 9 equal to E prime plus 1 to 7. So if you want to find the E prime, your exponent normalization, you will get 1 to 9 minus 1 to 7. And what is your answer? It will be 2. So this is your E prime. My writing is very ugly, so you can see here, if you convert, you're going to get 1 to 9. Your bias value for your single precision, it is 127. It is fixed already, as I mentioned, for single precision and also double precision. They have their own value of the bias value. And extract the so now extract the value of your fraction. You have 0, 1. So what is the meaning by 0, 1? 0, 1 in the binary. If you want to convert this one, you can see this is your, let's say, anything inside in front first. So this is 0.1 for your fraction. So if you want to convert it to the decimal, how you can do that? So this is the way for you. It is a 1 times to the power of minus 2. Why? Because you have to the power of 0, 0.1, 1, 2. 2 times to the right is going to have 1 times to minus 2. And this is you're going to get 0.25. If you don't know this step, please check back your digital logic subject, how you're going to convert from binary to decimal floating point. What methods that you need to apply. Okay, next you already get this value. Of course, if me directly, I can, okay, I know the format, then I can directly write out my decimal number. Okay, it is also shows you several ways you can try to do it. And apply the basic equation. This is your basic equation for your numbers, which is you got already your sign value, which is 1. You apply inside, you have 1 plus with your 1 plus your fraction number is 0.25, and multiply with 2 the power of e prime. Our e prime is 2, right? So you will get these things, the one that I show you just now. And when you apply this, you will get minus 1.25 times with 2, times with 4. Why 4? Because 2 the power of 2. And finally, you will get minus 5 past 10, which is decimal. From your long numbers decimal, from your single precision floating representation, then you get this number. So next, you have also another example. Please try to do so. Follow similar things for your single precision example. The only difference now, you are doing using the double precision, which means the value for your EB is already 11 bit. For your fraction is 52 bits. So try to get the decimal number from this double precision float. Okay, our last subtopic, which is under our floating point arithmetic. You're going to have addition and also multiplication only. So you have additions and multiplication. For addition and subtraction, it is necessary to ensure that both operations have the same exponent value. This may require shifting the radix point on one or the of the operation to achieve alignment. You can read it until I think it is not hard for you to understand this, but straightly we can see on the terms of the methods. For addition flow, how you're going to get the answer, or maybe the method for you to apply. So there is a method for you to apply for the addition in terms of your floating point number. You need to know this is we already learned on the bias exponent range. For single precision, we're going to have minus 1 to 6 until 1 to 7 for the bias exponent, and double precision will be minus 1022 until 1023. So instead of like this flowchart, we can simplify it using several steps. You're going to assume 4 decimal digit for fraction and 2 decimal digit for exponent. Step by step. Step number 1, you need to align the decimal point of the number that has the smallest exponent. Let's say I give you example what the meaning by this, which is if I have 2.02 plus 127.21. I just give you example. If you want to add, if you want to like deduct, you need to make it like similar radic point also. So this is one example when you want to adding the fraction number. But when you have something like 2 times 10 to the power of 2, and then you're going to add with 2 times 10 to the power of minus 1, you need to look into the exponent and align the decimal point of the number that has the smallest exponent. Which one is the smallest? So if this is the smallest, so you need to change it to align with your decimal point. Let's say over here, I'm going to change. Let's say I give you example. Let's say we're going to change to 0.2 times 10 to the power of minus 1. Why it's become minus 1 now? Because I move to the left. I'm going to add with 1. My exponent now is negative 1. And now I have plus 2 times 10 to the power of minus 1. My exponent now is similar, so I can directly add them together. I'm going to get to the 0.2 times 10 to the power of minus 1. That is the meaning by this, which is you need to make it similar for the exponent, and which one you need to choose, whether it is the biggest exponent or the smallest exponent. Now for step number 2, add the fraction, the one that I sure use, which is 0.2 and also 2. And later after you adding, you need to normalize the sum. Maybe your answer will be, although you add, let's say 0.2 and then you add with 20.02, so your answer will be 22.03. So this is not normalized, right? This is not normalized, therefore IEEE. So you need to move to normalize your sum. After you normalize your sum, you need to round the fraction. If the fraction does not fit the space reserve, so it has to be round out. So you need to normalize the fraction. Later you will see how many fractions that you can use. Depend on your space. For a single precision, for a double precision. And after you already fix it, you need to normalize it if needed for the final answer. Let's take a look at the example given here. Sometimes you was thinking that this is like a normal numbering, addition and numbering. You tambah je dua number, but it is in terms of the floating point. So how you going to add it? So you need to, first of all, you need to align the decimal point number that has the smallest exponent. Okay, when you have the smallest exponent, you will align it. Let's say you have 0.999 times with 10 to the power of 1. Here 1.610 times 10 to the power of minus 1. And this one is the smallest. That's why if you want this to be similar with the largest exponent that you have here, what you need to do? You need to get 1 here. That's why you need to add with 2, isn't it? To get 2 here, you need to move to the left. So you need to move to the left. 1, 2. 2 times, that's why you will get 0.0161 times 10 to the power of 1. After you have the similar similar exponent, you can get the answer. And sometimes, as mentioned, I give you an example just now, your value of your addition is not normalized, so you need to normalize it. You can see you need to move it to here, then you will get 2 over here, then it's normalized. Let's take a look. So this is the normalized versions. And as mentioned, please round out it into 4 decimal numbers only. What is yours? Okay, you have 1, 2, 3, 4, 5. So you just remove the at the back to be a 4 decimal fraction only. If you got 0.00155, if you want to round out, what happen is going to be 6, and this one will be removed. Kita panggil dia apa? Bundakan. And after we done with this, we need to check, is it normalized or not? If normalized, it's okay. If not normalized, you need to normalize again. But if no needs, that is your answer. Senang kan? Because this one is just a normal addition. Nombor perpuluhan yang you tambah. You can see example number 24. 23. Our number will be 0.5 plus minus 0.4375. What happened? This is 0.5 times 10 to the power of 0. Here will be negative 0.4375 times 10 to the power of 0. Add. You need to add these two numbers using binary. So it's already mentioned binary. You cannot add directly using your decimal number. That's why you need to convert first to binary. You need to convert to binary using a multiplication, repetition multiplication. When you convert, this one is we already done and learned together. Now you can see, if you convert, you will get 0.1 times 10 to the power of 0. Stop this first until here. And after that, you going to see you have these numbers and you convert it to be your fraction number. So this part you have 0.0111 times 10 to the power of 0. From here, you can see that if you want to convert after you're done with the conversions of binary, you need to similar and make it the exponent to be similar to each other. And first of all, after you convert, you need to normalize it first, right? Then your normalization will be like 1.0 When you move it to here, to the right, you're going to have 2 the power of 0 minus 1. Deduct with 1 because you move to the right. And while for this part, you're going to move 1, 2 times. That's why you're going to get 1.11 times 2 the power of 0 deduct with 2. And you will get this answer. After you get this, your smallest, this one is smallest. The smallest value, let's check here. Align decimal point of the numbers that has the smallest exponent. So the smallest will be this one. You need to align with the biggest. So you need to move to the left because you're going to add with 1, you will get -1 to similarize your exponent, your value of your exponent. Now you will get minus 0.111 for this part. And you add with your 1. Where is it? Step number 2. You're going to add only the value. You will get the normal number additions. You will get 0.001. Why? Because this value is negative. I forgot also about negative. Yeah, this one, that is a negative. After you're done, you're going to check your normalization is not normalized. You're going to move 1, 2, 3. 3 times to the right, it's going to be -3. So your answer will be -4 for the exponent. This is normalized already. And from here, you need to round out to 4 decimal digit fraction. Going to add 0.0000 until 4 times. Then that is your final answer. Is it normalized or not? Yes, it is normalized. So if let's say you want to convert this binary to decimal, you can also convert it. You have 1 times 2 the power of -4. What happened? You're going to get equal to 1 per 2 the power of 4. You will get 1/16. Then this is your answer. Okay, you can try this exercise. And now after we done with the addition, we're going to have the multiplication. Okay, now you can see you have over here step by step. Just now you have until 5 steps altogether in additions, but in your multiplication you got until 6 steps. And it's already mentioned, please assume 4 decimal digit only for the fraction and 2 decimal digit for the exponent. Now first step, add the exponent of the two number. Because this is multiplication, normal mathematicals, going to, like, let's say, okay, I have numbers of 4 times 10 to the power of 2 multiply with 2 times 10 to the power of 3. If I have these two numbers multiply, what I'm going to do, this value 4 times 2, and the 10 best, I'm going to multiply 10 to the power of 2 plus with my another power up exponent here. This is the meaning by your step number 1. Then you will get add times 10 to the power of 5. For additions, for multiplication, you're going to add your exponent. After that, You multiply the fraction, which is the one numbers that I multiply, and check whether your number is normalized or not. After you check the normalization, you need to round up until 4 decimal digit. And you double check again whether it's normalized or not. If already done, then you can proceed to your set of sign of product, whether it is negative or positive. Because this one under multiplication, it is not like additions and subtraction, which is if you have adding, is depend on the value, right? But for the multiplications, it's depend on the sign. If let's say you have positive and positive multiplication, you got positive. If you have positive and negative, you will get your negative numbers. And if negative and negative, you're going to get a positive number. Okay. Next is example number 24. Multiply these two decimal 14 point. Assume that 4 decimal digit for significance and 2 decimal digit for exponent. So you have these two number, and this is your value for your exponent. What you need to do first, you're going to add this exponent. You're going to get 5 in total. And if you have the bias to be considered, depend on the question, it will mention whether the bias need to be considered or not. And if it's bias need to be considered, you need to add 1 to 7 for single precision and 1 0 2 3 for double precision. Okay, step number 2, multiply with the fraction. You have this number and this number, you're going to do a normal multiplication mathematics. And you're going to get this value, and you have 1 2 3 4 5 6 6 1 2 3 4 5 6. So this is your answer. 10.2120 times 10 to the power of 5. Okay, because this one is from your answer here. So that is your answer before you go to the next step 3, which is normalization. Normalize your product. Then you need to move to the left. After you move to the left, you're going to add with 1. So this is your normalized answer. You need to round out to 4 decimal number. Then you will get this one. Check again whether it is normalized or not. Okay, it's normalized. And how about your sign of product? Because these two number is positive, that's why you will get positive numbers here. So you have another example number 25. This one is for multiplication. Multiply two binary floating point. You have this, and what first step, you're going to add these two number. Negative 1 add with negative 2, you're going to get negative 3. If the bias considered, going to have 1 to 7. And step number 2, you're going to normalize, you're going to just direct multiply it. Then you will get your answer 1, 2, 3, 4, 5, 6. 1.10000 and multiply with 2 the power of minus 3. You normalize the answer, whether it's normalized already, it's already normalized. Then it asks you to round out to your 4 decimal digit. That's why you get this one. And normalize again if needed. If not, you just ignore and check your answer, positive and negative. For sign, it's going to be negative. That's why your last, which is your sign of your product, you will have negative. Just that, it's very easy. And if you want to convert to decimal, you can do so. Try to do the exercise, and here is the summarizations for all we have learned throughout our module 2. Try also doing their exercise for the review question. So thank you. I hope if let's say you have any question, please direct contact me and try to do as many exercise as you can.